everyone, and welcome back to another episode of Access to Perspectives Conversations. Today we have Henry Didder as our guest, and I'm very happy to be able to welcome you. Welcome, Henry.
Hi.
Welcome to the show. And you are one of the co-founders of Science OS, which is AI facilitated um, analysis. It's a lot of tools in a package. Um, yeah, we hear more about that. But before we start and how you got into the entrepreneurial realms of things and developing the tool together with your colleagues, please tell us a little bit about your background and what got you interested in eventually getting engaged in the Science OS development.
Yeah, of course. Thank you very much for having me. So, my whole professional background has always been driven by a core belief, and that is that um, m- the progress of mankind, so that we become better society, so to say, that we advance as a species, but also together with all the other species on this planet, is that all this progress is driven by scientific advancement. So I believe that science is what drives us forward and what makes our lives better and the lives of others. And that already started in school. So during the end of my school time, I read the Allbuts, which is like the Bible of molecular cell biology. So for everyone who studied something regarding to molecular cell biology, they probably know the Allbuts.
Mm-hmm.
And then I decided to actually study molecular biotechnology. And from during my studies, I actually discovered that I'm not such a great fan of the actual bench work. So I I didn't like it was somewhat frustrating with all the experiments that failed, which is completely fair. But also I developed somewhat a reaction to the gloves that you have to wear in the labs. So my hands didn't like the gloves,
They
and for
were
all of that
allergic
I
the powder that they have. I think there's
the
also anti-allergic ones that you can get, but they're more expensive and not every lab has, I don't know, whether they
yeah,
have in
it's
stock.
not about the material. So it was the microclimate that is created within the gloves. That is another fancy way to say that I had sweaty hands.
Mm-hmm.
So
And you didn't
and
like that much. Okay.
no, my skin didn't like that to be then in the gloves all the time and everything. So the my my skin wrinkled and so on.
But
And
that's
then I thought
also
about
understandable. Also, first of all, sorry to interrupt at this point, but I think it's really crucial for you to mention that also the work, not only the research topic that you decide or end up studying during your PhD before and after, but also the working conditions and everything that comes into play. Not everything is fancy pants and happy engagement. And of course, there's compromises to be made to some extent, but if we really don't feel comfortable in the working environment that we find ourselves in, there's things we can change and either turn to office and desk work or switch jobs altogether, like you ended up doing. Sure, that's a journey which we will hear more about. So, and then the repetitiveness in molecular biology that you just briefly touched upon. I can
it.
also speak to that, and that's like frustrating to say the least. So it requires a whole lot of endurance and willingness to tweak whatever parameters and still, because biology is unpredictable, even if
Yeah.
you kind of isolate certain components into a small Eppendorf tube. Long story short, so yeah, I think many of us can relate to that, and then others are perfectly fine with it. And then, I mean, there's also an understanding, of course, that repetition is necessary in order also to prove a concept and to make sure the experiment as observed is valid. But to get to that point is a whole process, and not everybody is, wired to sit through.
No,
Yeah.
I have very deep respect for the people that I studied with and that are still working in the lab.
Mm.
And it was actually this respect for them that I thought about, okay, if this is not my way of contributing to scientific progress, what else can I do now that I have studied this? And this was then my way towards science communication. So I thought, okay, I've acquired the skill of understanding what the people in the lab do.
Hmm.
Many of them are actually not that big fans of communicating about science.
That's also
So
what I found, yeah.
what can I do to help them take something that I now can do with what I've studied and make their lives easier? And this is how I ended up in science communication and then worked in industry for some years. And then during that time, I actually came to the conclusion that if I now work in industry, maybe I should also have some formal education related to businesses. And this is why I did then also an MBA. And the MBA, like the experience of going back to the classroom, that actually helped me realize that my that I have a different expectation of myself of how I want to contribute to scientific progress and that I want to do something that directly benefits scientists and then the whole thing about okay, what can I do? What can I found something? Can I use what I've learned?
Mhm.
And then I talked an AI data
Wait,
scientist.
before you, because this combination that you just randomly mentioned, like first to study molecular biology and then adding a Master of Business Administration on top is not so often found. So what got you there? Was it just the frustration in biology that got you, no, let me try something completely different now? Or did you have some influence in your family or friend circle? Or what was it that drove you to the MBA?
Um, so it was a combination. One thing was just purely I wanted to have some basic academic education in that direction and and understand to some degree better what am I doing here in science communication
Mhm.
because this is in industry, it's a part of marketing. And marketing is a part of how to run a business. And so I wanted to understand, okay, what is it
Oh,
that what
okay.
I'm doing here, like how does that matter to all everything else related to business? Like what is finance and so on? Why are there people in accounting? What do they do all day long?
Hmm.
And this is I wanted to understand my role better. And then I also had my direct supervisor had an MBA. And when I approached him and told him I want to understand better what I'm actually doing here, he was very much in favor of that and supported that quite a lot and said, this is a great idea. You should do that. I think it will be a tremendous experience for you and um, understand the framework better and put everything into context. And so it was really purely driven by the academic thing. And when I started the MBA, I actually told my other classmates, I'm not interested in founding anything. So
Okay.
um, didn't hold for long then. So
Things might change. Okay,
yeah.
so the MBA came after the decision was made that you would switch towards science communication, but not leave research and, natural science research altogether, but just switching options and then finding a new position in that corner of the scientific discourse. Interesting. Okay. Well, I
And
think
you,
it's a very valuable addition to your professional skill set for sure. It's just that I haven't heard many seeking that combination of.
mhm. You're very right. When I take a look at the classmates I had during my MBA, I would say that 80 to 90% had a business degree already,
Mhm.
and they just put another type of business degree on top of that. And I think there was only one further biologist, then some engineers, some of them, but I definitely recommend that for every scientist who has an interest the in the world of business. You have actually a huge advantage if you study an MBA because you are already trained to think critically and observe things and evaluate them and also even quantify things. And this is something that is very highly valued if you can put that into a new context
Mhm.
that if you can apply that to business, because a lot of business decisions are more based on gut feelings than actual baseline research. But if you can back up your gut feelings,
Mhm.
um, it it's impressive to most people. Yeah. So it's a good combination, and it's way easier than studying any natural sciences.
Okay. Well, all right. So now, what was the route towards becoming a co-founder of Science OS then? How did you get in touch with the other founders, and what brought you to that position?
Oh, so that was 2 or 3 different situations that occurred. So I met the other 2 co-founders. That is Mark. Mark's an AI data scientist, and Andre. Andre is a software architect specialized in user experience and user interface to make things easy to use and intuitive. And I met them both through my previous employer where I worked in science communication because they were friends of the web developer of the company and so on. So we met through a different project at the previous company. This is how I got to know the people and the idea and that we want to do something about that together. That came from that I had a lecture during my MBA that discussed the network effect,
Mhm.
and that is something very interesting. It um, it is a way to show how what one person does contributes to the experience of someone else. So a tangible example for that is social media. You only start using a particular social media network if there are already people active on that social media network that you know and where you like what they post or want to connect with them. So, because all these other people are already on this other social media network, you join as well. So, the activity of other people reduces your barrier of entry, so to say. And that is fundamentally just a business perspective on that the community can do something that no one alone can do.
Mhm.
And and this is really important. And in science, it's the same thing. It is the scientific community that only through collaboration can go as far as we are going right now. No one can can advance science individually today anymore. Everything is far beyond the a level of complexity that one single mind and one single experience can grasp.
Mm.
And um, And then the second or the third thing was that I read some statistics about the amount of unpublished research data and the amount of money that states spend on R&D, because most of the R&D spendings are government spendings. That's the majority. And we spend roughly 2% of global GDP for R&D. And there's some estimate that about 98%, some say even way more than 98% of research data is never published. The consequence is that the states need to fund research that may have already happened. It's just that the data was never published because only the positive results were published.
Yeah.
So we spend a lot of money on research and recreate this unpublished data over and over again. So we could spend research, or the government could spend money on research way more effectively if we would all work together, share data openly and transparently with each other, and particularly the negative results that would be really important, combined with the network effect. And then I approached Mark and Andre and told them we have this huge problem um, that can only be solved if we bring people together. What can we do? How can we build a software tool that contributes to bringing people together, that contributes to collecting maybe also unpublished results and negative results. And Science OS is not there yet, not at all. But it's the idea what Science OS is supposed to become. That's why Science OS, like Science Operating System,
Mm-hmm.
because this is the path that we are seeking to let people collaborate and support them in all their activities.
Okay, so well, you mentioned also that negative results are hardly ever shared. That's been debated over, I mean, I think since like ever since research is being shared openly, that is like 1665 were the two first journals in France and the UK. Well, and then, okay, let's give it 100 years or two. But yeah, sharing negative results, as you said, like would actually save us a lot of extra effort, like 90% plus for sure, or whatever estimate you want to align. There are a handful only of, I mean, there are a couple of journals that explicitly publish negative results, and yet there's also understandable reasons why researchers shy away from doing that because it's also not incentivized at all in the system.
Mm.
Um,
I think that's actually the core problem. There's no reward for publishing negative results. You only get rewards for publishing positive results.
yeah, and then also you can never be sure that it's not your own fault. So what is the negative results? Like what you expect is not showing. So therefore, the whole hypothesis is wrong from the beginning, and then that might imply that your, professional skill set is insufficient. So you might, by exposing that, people might be afraid of being looked down at, whatever reason might. And then, yeah. So there's a lot of like there have been a couple of attempts and discussions that I also witnessed over the years to promote the sharing of negative results also like without the shaming aspect because it's still a result and to say we are is not even to say that we're not good enough to ask the right questions but also we are seeking at the edge of knowledge and we're basically digging in the dark as researchers in most cases especially in basic research. So, but yeah, so how do you think or envision that Science OS might solve their problem?
Yeah, so the fundamental premise is that we say, okay, in its core, science is a linear process.
Hmm.
So in the beginning, it starts with a hypothesis, and in the end, you do have some paper, or if it's an industry, you do have an internal R&D report, but you go from a hypothesis to a document to some degree in the end. And even though you are thrown back quite a lot, you tend to move forwards from idea to planning to experiment to data analysis to synthesis. So it is a somewhat linear process. And through all this process, you have specific activities, like during the hypothesis phase, you conduct some literature research. In the data analysis phase, you do statistical tests and so on. And all these activities, they they uh, they work on data that you either generate or that already exists. So data that already exists is like a research paper that you discover through literature research. Data that you generated is, of course, something from your experiments. But that means that essentially this whole process is just constantly discovering and working on data. And if we stop thinking about from a technological perspective that results or data are positive and negative, and to the scientists, they are positive and negative. Some data support the hypothesis, some data don't. Some data are just scrapped because the experiment itself failed for reasons that are not at all related to the hypothesis. That's just how it is. But if you just take all of this data and treat it purely as data and annotate it with everything that has happened in this process. So you generated some data with a specific device, and earlier you asked a specific question that actually made you use that device to generate the data. Then, if we support this whole process and provide guidance and help by uh, supplementing it with AI, we can help the scientist collect actually every piece of data through this process and share then also every piece of data. Even though the final publication may only mention like 2% of everything that has happened before that, all of that is still available and there and can then, and that is something that then the community needs to decide how open they want to be about it. They can then share all of these other 98% with other people,
Mm.
whether that needs some remuneration system where you share your data and you get remunerated if someone else uses it. I mean, you should most definitely at least be cited for things that you have done.
Mhm.
That is a completely different debate that should be more close to the point where we begin reaching that phase where you can actually share everything. And the idea of Science S is that through supporting this whole process, this gritty work of collecting all this data and annotating all this data so that someone else can even make use of it, that this should do the system automatically.
Yeah, that makes a lot of sense. Also, I wanted to point out something that I mentioned to you one earlier in a previous conversation, that Science OS and the acronym OS in my circles often refers to open science. And here with Science OS, it's representing operating system, as you mentioned. And yet what you describe is exactly what the open science movement, if you want to call it like that, and different streams within are calling for, is more transparency, reproducibility, accuracy in the processes, and like clear documentation for the purpose of accountability and basically values that we all share and subscribe to as researchers and human beings, I would say. So, um, so yeah, in that sense, there is a clear correlation between open science and operating system as to Science OS. And so to because you said that Science OS is, are you working towards that vision that the workflow can be described and managed within the system, right? Within Science OS, the software. And what can already be done as is, because you like the product is out, so when did you launch exactly and how long has it been?
So we actually started working on this with this first discussion was in summer 2022,
Mm-hmm.
that we started thinking about it. Then towards the end of 2022, we started playing around with the idea, and that was before ChatGPT. And we already had the conclusion that this these 2 decades of search engines that only provide lists of results and not answers should be over. And now we are actually at the point where this begins to be over and where we get answers instead of lists. Um, let's see where that continues to go. Um, but when we came together back then in 2022, we had to make a decision for where do we start?
Mm-hmm.
Because this is such a big vision and you could start everywhere. You could start in the hypothesis thing, you could start with the data analysis thing, you could start with the choose the right tech equipment thing. So because research is so vast and it's a linear process, you can start wherever you want to. And we sat together and thought, okay, what is it that a lot of scientists need to do and that um, doesn't generate so much new data, and that also a lot of scientists do not like so much. So they feel sense it more as a requirement and not as a joy. And through all these things, we came to the conclusion is working with literature. So it's finding new literature, it's gaining an overview, it is storing it, managing it, understanding research papers, and so on. And so we decided, okay, literature research is something that you, throughout the whole research process, constantly need to do. Wherever you are, you constantly have questions which you need to find answers to in published research. Um, we start with that, and that is what Science as today can do. So the most commonly used features is gain an overview about a new field. So um, as you've not seen it most likely yet, what does it look like? To some degree, like ChatGPT. So it is an AI chatbot which you can talk with. It's a so-called AI agent. That is nothing new. The idea for AI agents actually from the last century, and by that the last millennium. And the core idea is just that you do have a central decision-making unit, an AI, that can take an input, for example, the user asking a question, that can use tools. For example, our AI agent can use a search tool to browse the scientific database and then generate an output. In our case, that is answers or diagrams. And and that is what Science is. It's an AI agent. You can ask it question, you get answers based on published research. You can then go further. You can find also related papers. So we also have these things called citation networks, where we create a visual that shows you how the papers are citing each other. That's really important to find foundational papers because um, it helps you identify the papers that have been cited by all the literature out there. And these are like the papers that you really may want to know. You can upload full text papers and chat with them to assess the results. You can draft text. So there's like a reference manager built into ScienceOS itself so that you can upload all your documents and chat with them at once. And from my perspective, the really powerful thing is that all these things, gaining an overview, so just asking a question to our internal database, uh, chatting with specific PDFs that you uploaded,
Mhm.
uh, chatting with your reference manager, that all of this happens in the same chat. So you can, by asking questions, combine the database of Science.s with your own papers. So a more tangible example, let's assume you uploaded a research paper and you summarize it with Science.s and you come to a point where you are a bit confused by a result. So they state something in the paper and you say, well, that doesn't seem like the things that I personally know and experience with. I think this is wrong, or I at least would like to check if other people have come to the same conclusion. So what you would usually do when you read a paper is that you start going to any database like PubMed or Google Scholar, and you open a new tab and search for papers that say as this result or say the opposite. But in Science, as you don't need to do that, you just tell the AI, okay, this result over here, I'm a bit confused by it. Take a look at other papers.
Mhm.
What do other papers say about this? Have they found the same thing or have they found different results? And then because you have this central AI, this decision-making unit, it takes your input, your question, can you take a look at other papers? And it understands that it should not take a look in the PDF that you uploaded, but that it is supposed to find other papers and check if what this PDF says is what other people found. So it helps you to combine everything at once and become super efficient. That is the idea, so that you can then begin focusing on generating new data much faster. So
Yeah.
I also know that you've experimented a bit with Science as already. So what is it that you've done so far?
I've, well, first of all, I really appreciate that you provide those office hours where you walk interested people through some of the features as you've just touched upon here. So I attended that, and otherwise I haven't had time to go into deep analysis and like actual projects I'm working on, but that's on the to-do list here on my desk. But I've what you described and also what I've seen in the demo and just roughly try to begin with to test myself is that I find it fascinating. I can actually dig deep in one research article that you load into the system and then compare to also several to do your own internal literature analysis on pre-selected papers and articles and reports, as well as also searching through, as you mentioned, you use Semantic Scholar as the core or data source for the tool. And that's, yeah, as you also explained to me and as I've read elsewhere, is like the standard procedure for many similar tools and like gives you access to, I don't know, it's roughly 80% of the digitized content that we have in the world. I don't know, or in the world, in the,
Well, no one really knows.
yeah,
So
it's
it's,
really difficult to
yeah.
anticipate because also like where I work with working towards making African scholarship more discoverable, I'm very much aware that there's a lot of technical um, constraints and opportunities to make research from different parts of the world in different formats more or less available, whereas Semantic Scholars also bridges many of these gaps that persist in other systems. And yet, anyway, so back to the storyline. So I find it a really interesting and versatile tool that and looking into AI in a research context, we also discussed in the preparation that we touch on that a little bit further. So, what's the benefit from using a research specific AI tool over the more general tools such as ChatGPT, Claude, Perplexity is what I often turn to, Gemini, Google, which are also, as I understand, trained on I don't know if they use semantic scholars as well, but they're clearly more broadly set up, so they cannot go into as much depth in the scientific context. Um, and then there's other research specific, also literature analysis tools such as Research Rabbit, Elicit, Connected Papers. But from what I've seen and tested myself, each of these has dedicated features that they focus on, all of which make sense to some extent. And I give you the word and just one more thought because it's a bittersweet situation for me and also many others, I suppose, from from what I've heard from discussions, where to what extent do we want to rely on algorithms for our analyses? But then, given the body of literature that we now find digitized and published online, it's not anymore possible to manually screen through as one human being what's available out there within each of the research disciplines and research topics we might work on. Unless you know exactly where to look, and also, I mean, that's something I think we like. That's also my job as a trainer and consultant to inform researchers of what are the venues where you can find the research that other people might be working on within their discipline. So yeah, so the bittersweet is yes, there's a lot of opportunity, and the bitter part is like, okay, we lose not control so much, but can we still understand what's happening? And I think what I would like for us to remind ourselves to is we should not let go of the cognitive process and still understand and investigate where are these tools checking, what am I missing out on, and can I add to whatever result I get by using common knowledge or expertise knowledge from within my discipline. Okay, now I gave you a lot of many points to connect with and discuss further. But yeah, so what? No, but back to your question now. So there are other literature analysis tools to make sense of the vast amount that we find, and also to find guidance and what might be relevant to a research question or not. But yeah, to answer your question, I've like Science.OS is really convincing in what you just explained. You can look at a stack of articles, pre-select. You can discover articles that relate on to the research you're working on based on keywords, as you would use also Google Scholar or other venues or uh, now I'm just briefly lost for the PubMed was acronyms. Or whichever scholarly database you turn to. I would obviously always often recommend it before and ever again the Lens to use as a source, and then OpenAlex also nowadays, or Semantic Scholar for that matter. But now within a dedicated analysis tool like Science.OS, that now gives you a whole range of downstream analysis at hand where you can have the convenience of ChatGPT, of having a window to ask it questions and follow-ups, to then dig deeper into, okay, what am I really learning from this article? That question you should have in mind to begin with, but then you might also discover answers along the way, and then you can continue exploring further with that same article within and beyond. I'm not sure if I answered your question. But so I haven't. I have in the sense that I'm yet to explore further, but what I've seen already is quite convincing. Okay, what do you want to add?
Thank you very much. The I would break this into two segments. One thing is why use such tools at all, and then once you come to the conclusion that using such tools is a benefit, why Science.OS, or what, not necessarily why Science.OS, but how to select a tool that supports actually that you need to do, because in the end it's your research that needs to be supported, not a tool that needs to be supported by users. It's the other way around. But why use why not use ChatGPT, Perplexity, and so on? So there is two things. One thing is exactly the algorithms. So all these tools, ChatGPT, Perplexity, Gemini, and so on, what they have become today is, and what Perplexity was right from the start, is they are a combination of a large language model and a search engine. And what happens is you ask your question to the large language model. The large language model decides I use my search engine to find sources that help me answer that question. And this whole process is called retrieval augmented generation. So RAG systems, you call that, because they retrieve something and then they augment the large language model in its capacities with the retrieved documents. So these general tools like ChatGPT, Perplexity, and so on, they combine a general search engine with the large language model. And these general search engines are meant to support the general public. So they are not geared towards academic standards. Of course, they try to identify good sources, good web pages, good PDF documents, and so on that answer the question, but they don't put an emphasis on how frequently has this been cited, where has it been published, when has this been published, is this like how are the different sources that I retrieve through the search engine component, how are they referencing each other? And all these things are important academic standards. We have these metrics like how often has this paper been cited, because that helps us assess whether the community believes this is a valuable source and I should read it and it's relevant to me. Um, we have these components like how are things referencing each other to understand, is this a more foundational paper or is this a more subsequent paper? And we have these things like the publication date, where it really matters to us, is this new insights or may this potentially be outdated? And all these things are ingrained into the search algorithm of ScienceOS because it matters to the people that use ScienceOS. So essentially, compared with ChatGPT or Perplexity and so on, the search algorithm of ScienceOS factors in that the user is a scientist and not the general public.
Mhm.
Um, and the second thing is that also no database can be complete. Um, Semantic Scholar does not cover all scientific papers, but even if it would cover all scientific papers, it would still not be complete because there's gray literature that may be way more important in certain scientific areas than other ones. So, for example, in the social sciences, philosophy, and so on, the arts and everything, they have a very different format of publishing, and they do not necessarily publish in research papers. So it's important to acknowledge that the the database that you have and that you use to generate scientific answers can never be complete
Mm.
for a scientist. So you need to offer an easy way, an intuitive way to add or for users to add their own sources that really matter to them to the tool. And there it gets a bit tricky because uh, at most tools you have to pay for that to upload the research papers that matter to you. You need a Plus subscription with ChatGPT, or you need to have the expensive subscription with Perplexity and so on. You pay for uploading this, and also you just purely upload the file. It's not like a reference manager where you can see the title, the abstract, and so on. That's not the case at ScienceOS because we understand that it's so fundamental that you can augment the internal database with your own documents. So that's completely for free to upload all your stuff. And through both these things, like using specialized search engines and being able to augment what is there in the search database, that is why you should use a science tool, a science AI assistant, and not ChatGPT. It's the same reason why we use mostly Google Scholar, a specialized search engine, and not Google to
Mhm.
find research papers. Both are search engines, but one is specialized for the scientific use case.
Mhm.
And then ac across the board of all these different tools that now exist and are available, like you mentioned, Elicit. Um, Elicit is pretty expensive, so that is a little bit unfortunate because I also think it's a fantastic tool. It can do something that ScienceOS cannot do, and that is write meta reviews. So Elicit was built to generate these important meta studies that you can automate them. That is something that ScienceOS cannot do. And I think that's really excellent and that it's a great tool for that very specific use case.
But then
Research,
also,
yeah,
I mean, that used to be a common practice also before the explosion of literature,
yeah,
for research to write reviews of like basically summarized reports on a stack of papers within a research topic. And yes, that can now be done automatically, but then don't we lose and um yeah, lose the human cognitive. Anyway, so maybe
that
it's for good reasons that it's expensive. Anyways, also it's not to compare which one is better or worse because each of these tools has been developed for a particular purpose. So I didn't want to put you on the spot and saying like, yeah, this is really good. Anyway, I'm not even, I don't even think you were going to go there. But like, because just assuming that some of the people who are listening to us might already have tested Research Rabbit or connected papers, each of which has a dedicated purpose on how they exist and why and how they were developed. And yet Science.OS brings the features that you mentioned and then a deeper analysis and the convenience of a chatbot or chat window to explore further from that specific article or a selection of articles. And then you can directly verify the information as well, because it gives you technical assistance to support the cognitive process that you're still expected to execute as a researcher.
Yeah, that is exactly the argument I also see here. So if um, if the process itself becomes a little bit more efficient, and by that, so to say, also easier, then I think it is fair to expect more of scientists. So we always, for example, said that we should conduct critical literature review. We should not only find papers that support our argumentation, but also find papers that contradict our arguments.
Mm.
But who really did that? Because it already takes a huge amount of time to find the papers that support the results that you found. That's already a week of work. And then it takes another week of work to find papers that contradict you. That's even more complicated because you need to think the other way around, because you cannot put into PubMed or Google Scholar, find me a paper that says the opposite.
But
That
that
doesn't work.
yeah, but that was Side AI was built for, right?
It it tries to do something like that, but it takes a particular paper
Mm-hmm.
and then finds
Oh,
other papers that say the same or the other one.
from the
But so it also helps you make finding or make a very comprehensive literature review easier. But now with the advancement of technology like Science and so on, there's really no reason anymore to not do critical literature review because it has become so easy. You just go into the chat, you describe your result, you say, I found this and that, find me papers that have found something similar, find me papers that have found something opposite.
mm.
It's now two questions. And that the so the perspective of that things get too easy, that should actually lead to then let's be more ambitious.
And
Like with the
also, yeah, just to add to what you just said, that's also like one of the core expectations I have onto myself as a researcher or any researcher out there to be our worst critic. I mean, not the worst, but like the most critical critic, and to question our findings, not, well, to be extra sure that what we found is actually true and
yeah
not relying only on the machines, but also checking, okay, what have other previous and um, concurrent studies found? What's, yeah, and I mean, the competition is real. I mean, unfortunately, the imposed competition because research intends to be collaborative. And yet, but yeah, I think maybe that's also what now where we can use technology, trying to find a yeah, because it feels a bit overwhelming at times to think about AI and the
mhm.
huge amounts of literature out there. But now we've come to a point where we agree that it's not humanly possible anymore to make sense of the literature. But we have now advanced AI tools at hand that are also self-critical by design, not through the algorithm, but through the programmers and the managing teams behind, to allow researchers now to ask the right questions again, not only to the research they're looking at, but also the tools they use, including AI. Yeah.
Yeah, I fully agree. Also, the aspect of um, transparently discussing how we use such tools is very important because there's this huge risk that everyone is using it and no one is admitting it. And that that has a that could lead to that we teach, for example, students to not use the tools, but secretly use them. And that's just it's contradicting what also the open science movement is about. So AI is just a tool. We disclose all other tools that we use. So we should also disclose AI as a tool. It's really just an algorithm. It's no magic.
Mm-hmm. Yeah. Okay. Oh, that brings me to the privacy aspect, because I've seen on your website and also in our discussions before that you also hold privacy um, high up of your users. So the training of the algorithm happens purely on the data source, basically Semantic Scholar.
So
Or do you have like a selection of users who proactive or explicitly agree on
no,
sharing certain data and you don't?
no. It's all the user input and all the by that also generated output, and user input can be the questions that you ask, but it's of course also if you upload a research paper, that is also an input. If you and the answers that you generate, because they are derived from your input, we also see them as the property of the users. So it is their work that can be potentially extremely valuable, what people are doing. So we treat that very carefully, and that it does not belong to us, but it does belong exclusively to the users. There's no training on inputs and outputs. Um, on the uploads, if you upload a research paper, or it doesn't need to be a research paper, it needs to be a PDF. That can be anything. It is encrypted and stored in your account. We cannot access it. No one else can access it if you don't share it within Science as with your colleagues. So this is really important to us to make sure that everything that you do in Science as belongs to you, because it's a tool. It
Mhm.
should be yours. And to be extra cautious, we therefore also do all the storing of data in Europe, so that all the strict EU data privacy regulations affect the
Yeah.
user data.
That's GDPR, the general, what is it? GDPR.
Data protection regulation.
Yeah.
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 I mean, we are based in the EU, so we ourselves as a company have to adhere to the EU um, data privacy regulation anyways,
Mm-hmm.
but um, the EU GDPR does not necessarily need to mean that also all the user data needs to be in the European Union. It just means that it needs to be transparent where the data is. But if you're transparent that your data is in some server in the US, that is transparent, but we go a step further and say, no, everything has to stay within the European Union, because if the server is outside of the European Union, that means that it is on the ground of a different government. And if that different government decides, well, we don't like to adhere to protecting the data of your users anymore, they can simply do that. And you, as a European company, would not be able to do anything about it,
Mm-hmm.
because it's a server on the grounds of a different nation. So the only way that we can make sure that EU data protection actually is taken seriously is by having the data in the European Union.
Mm-hmm.
So the only risk is that the European Union decides that data protection is not worth anything anymore.
Mm-hmm.
And that appears to be extremely unlikely for the foreseeable future.
Yeah, especially in the times we currently live in. Enough said about politics.
Yeah.
Yeah, thanks. Okay, that also answers or speaks to a question that we bounced beforehand, like to what extent do you ensure reliability and transparency of the information provided through the tool by basically you get what's uploaded and also what's uploaded or what's sourced from Semantic Scholar, and within the tool you already always see the actual source. And that I think is also just as a side benefit of Perplexity over ChatGPT, because also there you have the source always listed alongside the response, but then the response might still be different and also what is misleading from the actual information provided in the source, which cannot happen here because there's a spotlight on the source straight without, I mean, yeah.
It can still happen, so the system can still misinterpret, so to say, the
Mhm.
source. It can just understand it in the wrong way, like a human can misinterpret
Yeah.
a source. That can still happen. Um, but it's important that the user can very quickly verify whether that happened. So it needs to be as easy and as comfortable
Mhm.
and within Science as it's just clicking on the source and then you can see what it says. So um, because the technology is not there and may actually never be there, that it is 100% accurate all the time. So you need to find a way to make it as easy for the user to verify the
Yeah.
claim. And that is by just clicking on it.
Yeah, thanks for clarifying that further and the openness. It also speaks to transparency. And to add here, um, what? Yeah, no, I agree. There will hardly ever be 100% accuracy in any process. Oh yeah, and what I wanted to add is that differentiates a researcher from a common citizen, because as citizens we also have the rights, or we should be able to rely on what's being said and done. And yet, as a researcher, we have, by the very definition of our profession, we have to go the extra mile and check the sources, because otherwise we'd just be citizens and then not deserve the title of researcher. But that's
That's a very fair point. Yeah, that is what our job is, verifying data and information. Yeah.
okay, cool. So now with the growing adoption of AI, how does Science OS and how do you with the team approach issues around research integrity, plagiarism, and the responsible or irresponsible use of AI in science? Are you following the debates and discussions with research integrity, and especially the publishers are basically at the tip of their toes now with making sense? Also, to an earlier example, I mentioned that people might shy away from disclosing they're actually using AI, but then it also happened that if they did and they wanted to disclose a responsible use of the same, then a journal, not sure if I can retrieve the actual report of that, but sometimes also happen that the journal then punishes
Hmm.
upfront disclosure, where it wasn't even like where it was just used as an assistant, but the journal editorial team had decided no use of AI whatsoever, where it's anyways difficult to draw a line.
Mm.
But coming back to the question of integrity and responsible use, so I don't know, is it possible for you to say within just a few sentences something about that from different from what we already discussed?
I think it is really about this transparent documentation. I mean,
Mm.
most publishers are now coming to the conclusion that this is just the reality, and now we are in this place where the different journals have very different guidelines for how you should disclose it. So some are very strict and say, yeah, you can only use it for grammar and for nothing else. And you have to sign a document that you only used it for grammar at best. And others are way more open and say, well, you can use it for whatever you want to use it, document it, spell it out, put it as an attachment and explain what you did, put some example prompts there so that other people can see how you use that. And you still need to sign that the whole um, the whole scientific analysis and the whole thinking and so on and the idea and so on, that was still yours. So you have to still commit to, I'm still the researcher in control of these things. They don't do things proactively. Um, and this means that you are now in the situation where you, before you hand in a manuscript, you need to very carefully check what are the guidelines for this journal and for this journal and so on. So it's a bit confusing, and this will probably the system will iron out itself. So this will come to one general guideline over the course of the time. And it looks like that the guideline will very much be document transparently how you used it,
Hmm.
provide some examples. So
But I found in my own work when I work with team colleagues on projects and then you turn to large language models for, project development or um, also working on certain sections of analysis. It's important also for internal use to document, just as in the research process. Use document what tools you use for what purpose, the prompts in this case, what questions did you ask and how exactly, which then led to whatever results list. I also led myself and our team keep the link to the results list of the
mm,
tools that we use until the project is documented, reported, and finished and closed. Because we might, first of all, while it's ongoing, we might still want to come back and ask follow-up questions or recreate how we ended up with whatever question and point made. And it's just part of the process now. So it's important to document the prompts, the results, and any step in between. Yeah,
that
also
is
for ourselves.
that is actually something that we are working on right now in ScienceOS to make it easier that you can just click a button and it documents all of this for you and stores it into a specific space. Um,
Like history, like the chat history with a tool.
well,
I
the
don't
chat history is one thing that exists, so where you can go to previous chats and so on, but you can also, because in the end, you have this whole chat to find some information.
know.
So you chat for as long until you get to an answer that is actually the one answer you were looking for. So the the end result is actually just this one particular answer. That's what you're interested in. So we are implementing a way that you can store these answers and share them also with your colleagues. So if you can collaborate in Science and have like shared workspaces, and then one colleague can share an answer that they worked on with the whole team, and then potentially another user can take the answer and start their own chat from this generated answer. So for you discover something in Science as you say, oh, this is interesting, all the team should know. And then someone else reads it, but has some additional questions. So they can just take this answer and start a new chat based on that and ask the questions they have regarding this particular answer. So this is what we're working on right now
Mhm.
to ingrain this documentation and sharing in a collaborative research setting into Science.
That's so cool. Thanks for doing that. I mean, it's cool because it's useful. And then you mentioned that there might also, well, responsible use is asking for disclosure and protocols, like you explained and mentioned that you're working on. Um, so yeah, so basically, have you seen journal editors to provide templates for that to make that as easy as possible?
Mm,
Not as much, right? It's
no,
really
so
general.
they just have their guidelines, but not a template. Um, and that is something that actually a friend of us. Her name is Olja, worked with us on exactly this subject
Mhm.
because even if we say that our users should transparently document all of this, we have no control over them. If they want to act badly, they can. We cannot make sure that they document what they're doing. The only thing that we can do is make it make acting ethically and with academic integrity easier.
Yeah.
So we can just make it not as annoying to document your disclosure. So this is why we worked on a disclosure template. Um, of course, in the template it says I used Science S version this and that for the following things, and then you just have to select some checkboxes and put some example prompts in there, and that's it. But you can also just delete the word Science OS from it and put any other tool into it, and the template works. So
And is
it's
that template available already within the system?
uh, it's on the website. So
Oh,
you just go to the website to the tutorials, and there's one how to disclose AI usage, and then there you can download a Word template that is, and
really?
we're working on adding it also into the app.
And that's really brilliant because most people would just, shy away from any disclosure because they might feel, okay, whatever I start disclosing, maybe it's not enough. So why start with that to begin with? Or it might be too much and a lot of work if you are really detailed and accurate about it. But I think the minimum requirement is to acknowledge, yes, I've used this and that tool for that purpose, and then maybe adding the prompt. And that's already an opportunity for reproducibility and
Mhm.
transparency. So yeah, I think for you guys to have considered that adding the template and that is a huge step forward in guidance for any researcher and making surely their life easier with it in that regard. All right, we've discussed for quite some time. There's a lot of aspects to go into details as we've done. But now coming towards a close, I would still like to hear from you. As in, you say on the website there's partnership opportunities, and particularly you want to collaborate with non-profit organizations, but also for profit, I suppose. So, what is your approach, or what's your vision with proactively seeking partnership engagements of different sorts, and what has the experience been so far?
So the partnership program for nonprofits that we offer is that we see that there are scientists who go way beyond their expected responsibility of their actual research work, and they form um, NGOs, they form nonprofits, they form organizations that host meetings, and so on, all with the pure intent to um, distribute the findings of their field even more. So they set up nonprofits that help um, people working in agriculture to make better use of the scientific advancements that we've made in researching agriculture. They set up conferences and all these things, and they do this in their spare time, most of them, without any financial rewards usually. And because they do go this extra mile, we say that we give them something or we provide them with something with an offer, and that is that if these partner or these nonprofits want to join the partnership program, what they get is a discount code that they can share with their members. They get onboarding webinars so that we can help them explain what can Science OS do, what can it not do, and they get the chance to um, uh, include themselves into the development of the app, so provide feedback. And that is the thing that we, so to say, gain from the partnership. So the nonprofit gets the discount codes that they can share with their users. They don't have to make use of it if they don't want to use Science.OS, and the nonprofit doesn't have to pay anything for it. It's just a discount code. It's very, very easy to manage. No extra work for the nonprofit.
Mhm.
The webinar is simple. Um, but the thing is that the researchers in these communities, in these nonprofits, tend to be scientists who are very engaged because they don't even do work, they even try to make their work more relevant, their work better, and so on. So they tend to be super engaged people. And we get, so to say, access to them through the partnership program. So most of the people that assess what we develop at Science.OS are also based on, or are also part of these communities because they just have this personal urge to contribute and help with something. So if we ask them, hey, can you take a look at this? Does it work like you expect? What is not working, and so on? They provide really detailed feedback that helps us to make Science.OS better than for everyone. So um, is this partnership is the least effort possible for the nonprofit. That is what we want to make sure so that they don't have any extra work because they already do extra work. And in exchange, we get access to people that really want to share what is working and what is not.
Mhm. So that's basically where you fill the gap and the void that you create, so to say, by not observing or storing the input of the user and analyzing any of the processes that were generated through the user. But then here you get direct feedback, user feedback in a consolidated manner. Makes a lot of
And,
sense.
and usually you get way more surprising feedback that way. So if you can watch them, what they do, you suddenly understand that you made something way too complicated.
Mm.
So if you just tell them, hey, do this and that, and then just watch them do it, then in most cases you see them struggle. Like, and it's just things like finding a button
Mm.
because it's
Yeah,
not
yeah,
highlighted enough and things
yeah.
like that. And this helps us make very simple changes, change the color of the button and things like that to make it more intuitive and easier to use.
Okay. Yeah. So then you actually have meetings where you give them tasks to execute, which again helps them in using the tool and educates them while you learn about the user intuitiveness of your tool. Nice.
And they tend to tell you even more. So
Yeah. Cool. Okay. So, what's the next steps that you're gonna take? What's the future outlook, short term? What can you already see at the horizon?
So
Is
the thing that is very much coming, the next is that we integrate Zotero, so the open access reference manager that you can link that
that's
to
also probably
Science.OS.
cool. I asked you that question explicitly. Was it in a demo before? It was like, oh, I've just kind of renewed my library in Zotero. Is this now redundant because you're sourcing everything from Semantic Scholar? But no, you can use your Zotero library and then very soon connect it to your Science.OS system.
Yeah, it's like the first user interviews about this new feature will be in 2 days.
Yeah,
So
okay.
that's
So,
the first round, then the day after is the second round. And then we'll probably have to do some revisions, what is not working, what's not intuitive. And so the timeline is most likely at some point in August that will be possible. And then the other things that we're working on is like these shared saved answers, so make collaborating easier within Science.OS.
mm,
And from that, we want to go into the directions of solving one fundamental problem that we generally see with these tools, and that is that they only do something if you tell them to do something. So the 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 potential of all these tools is way bigger than what we're doing today. So in in a chat, the AI will do nothing until you ask for something or tell something. And it doesn't have to be that way. So the AI could also, based on what you've done so far, for example, check what has been newly published and recommend to you, oh, there have been two new papers that I think that are super relevant to what you're researching on, just published last week. Do you want to check them?
Mm.
Or, hey, you are constantly asking questions into that direction, but you're like missing out to think into that direction. Have you considered um, taking this approach to the problem that you are discussing? So make it a bit more proactive and provide you with inspiration for where to go as well. So this is the
Yeah.
the big thing that we see next.
I would just hope that you add a on and off switch to that feature because I just find myself already jumping into rabbit holes everywhere. Because with these constant prompts by the tool to the user, that, that might just distract me. I come in using the tool with a clear agenda, and then 5 hours later, I'm still there exploring whatever, which is totally off track from what I originally anticipated. So, as much as,
And that's
and that can be intuitive, like this can be done on purpose. And I vlog 2 hours of work for this part of work, which is part of work, for this particular task. And I know it instead of, and then having a clear desk and just seeing my own prompts to the tool and nothing coming back at me other than the results I've asked for. Because this, I think, is a problem with our time with social media and, by constantly blinking, oh, have you seen this? Have you seen that? It's like, much worse than window shopping because there you can at least decide the speed of pace of walking by the windows or slow down and explore in depth. But here, it's like constant information and more, and yeah, and there's still
Mhm.
more. Like, I I feel exhausted just thinking about it.
No, I agree. So that should not be something that just constantly harasses you. It's something that should be very carefully timed, like maybe once a week, maybe every second week, with just
Yeah,
one idea.
or like just a wish list, like within the chat window, then having a button like, do you want to explore further? And then, yes, I want to deliberately, I decide I want to see more options and then get recommendations. Because already in these general LLMs that we mentioned before, um, as much as it's interesting, but then again, I find myself being so distracted from what I actually have to do. And then I think I'm still on the task, but I'm diverted. Anyways, but yeah,
No,
you may
that's a
not
very good point. It's
take that
very
in.
valuable user feedback. Maybe have a way to turn off these proactive things to keep a clean desk and not clutter everything.
Because also that's another expectation I have of researchers and thinking back about myself and my own behavior is to come with an agenda to a research question and a step in the workflow and not being presented all kinds of options. Of course, this can come with discussing with colleagues or a tool like Science.OS, but then that should be on my own demand. Um, and the brains are easily, how do you say, influenced, even professional, I mean, trained brains, like, anyways, let's not go into dissecting words. Okay, I think we've exhausted my brain for this, but it's been really interesting to talk to you and dig into the history and the making of Science.OS and how far you've come already in such a short time. And what I find particularly interesting is also the dedication and responsible use in or responsible creation of the tool to begin with, and thoughtfulness of each of the features that you present and how they compare to other existing tools out there, each of which has their own value and purpose. And I think what's now challenging to the users, but the challenge has always been there, it just keeps changing over time, is that there's a multitude of tools out there. And now the important thing is, and this is the purpose of this podcast episode, to hear about a particular tool, get to know a little bit about the humans behind. Thanks for representing. And then also the intention that you had in creating the tool and what it can be useful for. And then it's on us researchers or them researchers to get a better understanding of the whereabouts and howabouts, and then make a decision, conscious decisions on what tools to use for what purpose, and also what combination of tools. And that may change over time. And as you said, like with the network effect that you mentioned, that's also something that I often suggest in trainings, like ask around during lunch, coffee breaks, ask what your colleagues are using for what step in the process, what AI tools or non-AI tools, what cognitive processes and methods they apply, and then test whatever works for you. And it's not that any of us misses out by not using, I mean, you may, but also there's a multitude of tools out there. And I just find Science2S, hence the invitation for the session here, has not only a lot of potential, but also proven concept of what it can already do and where you're heading towards. And with that, all the best, and thanks very much for sharing in this conversation. Thank you, Henry.
Thank you very much for having me. It was a huge joy. It's always a great experience to talk with researchers because we always learn so much, and we are very proud to be in the spot that we can actually support researchers.
So until next time.